Good morning, good afternoon, and good evening, everyone. This is our second annual event regarding our technology demonstrations. We've made a tremendous amount of progress over the last 2 years, and we're doing this event slightly differently. In the past, we've met together face-to-face, but as Green Touch also wants to reduce its overall carbon footprint, we've decided to do this one as a webinar series, and you'll be able to catch it live as well as archived as well. So we're very excited to have you here. We're very excited about the upcoming technology demonstration that you'll see by video. Remember, Green Touch has the ambitious goal of improving the energy efficiency of networks by a factor of 1,000. And when we launched Green Touch just a few years ago, we started with about 15 founding members and that goal based on one theoretical result. But remember, in those early days, that Green Touch is also there to demonstrate these technologies, and that's what really makes it unique as a consortium. Of course, we collaborate. Of course, we come together and exchange ideas and different perspectives of technology, evolution, and whatnot. But we are also here to demonstrate in real, tangible ways the path forward. And so last year, we demonstrated the world's first large-scale antenna system, which was able to improve the energy efficiency of a wireless system by a factor of 16, but more importantly, showed a path to extend that on up through the eventual wireless goal. Today, we're very, very pleased to announce that we're going to show you again through video a wireline demonstration. Very excited about this. But on the membership side as well, we've grown from that 15 people, 15 organizations, up to now above 50. So we have 54 members. Actually, I was just notified that today we had another member join, so we have 55 members in Green Touch, and it continually gets traction both in terms of its participation with over 300 scientists worldwide participating, as well as these technology demonstrations. So without further ado, I will hand the meeting over to Peter Vetter. Peter is the chairman of the Wireline working group within Green Touch. He's also the principal investigator for the BIPON technology research project with a few other collaborators. And Peter will go through how the technology works and then conclude with a demo of how this technology actually operates. Peter?
Thank you, G. So today we are very excited to announce a new technology for fiber to the home that allows to improve the efficiency by more than an order of magnitude compared to today's technology. Fiber to the home is already a very efficient access technology, but we realized that the way the protocol is designed today, actually 99% of the data is unnecessarily processed. I'll explain that in a minute, how that is. But we will be showing you a new technology that saves a couple of watts per user. And if you multiply that by the 142 million subscribers that are forecasted worldwide for fiber to the home, this is a huge impact. This is the equivalent of having 500,000 cars. So we are taking, by redesigning, rethinking the protocol of fiber to the home, we're taking 500,000 cars off the road, the equivalent of all the cars in a city like San Francisco. So we're very proud of this technology. We call it bit interleaving PON or BIPON. And it's the result of a collaboration in Green Touch with Bell Labs, IMEC, Indria, and Orange. And they're also here with us in the panel to answer questions later. But let's first explain how fiber to the home works today. So fiber to the home, most of the technologies deployed today are based on passive optical networks. And on such a passive optical star, the data is broadcasted to all the homes connected in a time division multiplexing fashion. Today is 2.5 gigabit. The most recent standard is 10 gigabit per second. And in the home, you have an optical network unit, or an ONU, that is processing all that incoming data and is selecting the relevant data packets that are bound to this home. This optical network unit actually is the most power-hungry part in the total system, and that's why a lot of the research is focusing on the optical network unit. And already in today's standard, there is a way of improving the energy efficiency and the power consumption in optical network unit by means of cyclic sleep mode. And we will be using this cyclic sleep mode as a reference to benchmark our new technology, the BiPON. This cyclic sleep mode, as we will see later, gives us already a power reduction of about 50%. So this is important for today's standards and gives already an appreciable improvement. But in GreenTouch, we realized we should do a lot better with the ambition of having orders of magnitude improvement in the network. We should come up with fundamental new approaches. So we started rethinking the protocol, and we zoomed in on what happens actually in the optical network unit. And we realized that actually there's a whole sequence of processing steps: synchronization, descrambling, error decoding, deframing, and that happens on the total data stream of 10 gigabit per second. And actually, the end user is only consuming tens of megabit per second. So that's why we realized actually 99% of the data is unnecessarily processed and then dropped. And then we were thinking, can't we do the things differently? Can't we arrange the frames in a different way? And then we came up with a new protocol called bit interleaving PON. In bit interleaving PON, the data is no longer organized in packets, but the relevant bits are spaced in time with a clock periodicity that matches the user rate. So in this example here, 10 megabit per second. So on the incoming line on the fiber, you have 10 gigabit per second, and every 1 bit in 1,000 needs to be selected. And that can be done a lot earlier in the pipeline, right behind the receiver and the clock and data recovery. So the irrelevant data is not unnecessarily processed. Only the relevant data is processed at a much lower clock rate, 10 megabit per second. And that gives us this huge saving. So we achieve more than an order of magnitude just by rethinking the protocol. We are now going to show you a demo, and Dusan Shuvakovic, who is the inventor of this bit interleaving PON protocol, will explain you how it all works.
In order to evaluate the power savings of bit interleaving PON, we have built a prototype of bit interleaving PON as well as a prototype of the standard XG PON in our lab. In our prototype, we have used FPGAs, which stands for Field Programmable Gate Arrays. These are chips that can be programmed and implement different hardware based on that program. These chips are known not to be very energy efficient because they have very high static power consumption. However, in our measurements, we are able to subtract static power consumption and measure only the dynamic consumption, which gives us a good indication of what the real power in the ASIC implementation would be. We have implemented central office equipment as well as customer premises equipment known as ONUs. In the other room behind me, you can see the central office where we have a video server streaming video to the home. Also, we have two separate PONs with central office equipment known as optical line termination, OLT. We have two OLTs, one for each PON, and we have a switch that distributes video signal to both PONs. Between these two rooms, we have optical fiber that delivers the optical signal to the customer premises equipment, also known as the ONU. And I'm going to show you what ONU looks like, what you would normally have in your home. In our setup, the ONU is implemented using these two boards that have identical hardware However, they are programmed differently for the standard XG-PON and for our bit interleaving PON. As you can see on the screen, we are streaming a video, in this case Lord of the Rings. This is something you would do in your home. And all the traffic is going through our bit interleaved PON, and the same traffic is also delivered to the standard XG-PON ONU. We are measuring the power consumption of both ONUs while performing this operation. So you can see on the first screen that XG-PON power consumption is about 3.7 watts of dynamic power. To be perfectly fair to the standard implementation, we are also implementing it with sleep modes, and I'm going to show you how much the power can be reduced if this XG-PON ONU is switched to the operation in sleep mode. As you can see, the power goes down from about 3.5 watts to about 2.5 watts. This is a significant power saving, but still it's less than 50%. On the second screen, you can see the power consumption of our bit interleaving ONU, which is obviously far lower than that of XG-PON. Currently, we are measuring about 60 milliwatts, which is about 30 to 50 times less than the power consumption of XG-PON, depending on the mode in which XG-PON is operating. Further, we have achieved scalability of the power consumption in bit interleaved ONU. So when there is no traffic, actually our ONU is going to consume less power. And if I pull out the optical fiber from the ONU, you can see that the video will stop. And also the meter is showing lower power consumption by another 50%. Next, we're going to show you the maximum power of our bit interleaving ONU, which is measured while streaming the maximum bit rate to the ONU. This bit rate is around 1 gigabit per second.
Well, thank you, Dusan. So we're very excited about this result. Just think about it. We identified 99% of the data is unnecessarily processed in an ONU, in an optical network unit today. By rethinking the protocol, we achieved more than an order of magnitude efficiency improvement. We have shown you a few watts improvements per ONU. Now you may think, why does that matter? But just multiply that by the 150 million fiber to the home subscribers that are forecasted globally. If you multiply that, that's the equivalent carbon footprint of 500,000 cars. So we're taking, say, all the cars of San Francisco off the road. I'm very proud of the teamwork, and we will let you hear the partners say how they collaborated with us in GreenTouch and what this means for future fiber to the home network.
At Orange Labs, we imagine the network that powers the world's communications, and we must make sure that we do so responsibly. Bit interleaving PON technology is not only an innovation that pushes our industry forward, but also a symbol of our corporate responsibility to reduce the power consumptions of our networks and how the networks can contribute to the European objective to reduce CO2 emissions by 20% by 2020. The slim mode can have an immediate impact on current fiber to the home systems, while the bit interleaving PON is an attractive long-term solution for low-power access network. We are very interested to test this demo in our labs in France because of what it holds for the future. It represents yet another milestone in the GreenTouch program, and we are happy to have a part in this event.
IMAC prides itself on powering a sustainable world, and VPON demonstrates how the GreenTouch mission dovetails nicely into our own mission. Ultra-low power operation is an important part of our own mission, and the VPON technology will move us one step closer to realizing this. Today's announcement shows what collaboration with the best and the brightest in the industry is capable of creating. We worked with Bell Labs to integrate their invention with our own ultra-efficient clock and data recovery solution into a custom chip. We'll be showing this system at an exhibition at the Telecommunication Industry Association Conference in Dallas in June.
At INRIA, the French National Institute for Research in Computer Science and Control, we are passionate about advanced digital technologies to solve tomorrow's problem. The bit interleaving concept is a kind of technology we are excited to be part of. Using BPON allows for a very simple and low-power connectivity CPE at home. This will make a significant impact on the industry overall. It also fits into our Green Touch research on virtual home gateway, which challenges convention by taking out of the home gateway and deploy them in virtual cloud infrastructure. These two concepts will be demonstrated during the showcase in TIA in June 2012.
Great stuff. This is exciting stuff to deal with, and again, it's collaboration at work. As we see the collaboration across the community to pull this together, as well as collaboration last year around the wireless side. Remember that there's work now being done not only in wireless and wireline technologies, but core switching and routing, core optical networks, services, application, and trends. We've also, because of the progress of the work, have started up a new pre-standardization group. All of this to accelerate and get these ideas out there and starting to make real results and tangible impact. To also help us with a broader view, we have invited Jung Kim, president of Bell Laboratories, to come and give us a perspective of Green Touch and in that broader context. Jung?
Thanks, G. You and I discussed this Green Touch 2.5 years ago, and we both struggled quite a bit in terms of what would be the goal that we should aim, and we came down to a factor of 1,000 improvement and actually demonstrating that. And question was, why so ambitious? And the answer that we actually gave ourselves was that if goal is so ambitious, we know that nobody can do it alone. It requires collaboration of some of the brightest minds across the industry, from networking to to device and whatnot. And we probably have to invent some new things because we don't know how to do it actually. We couldn't sleep really well, but we were able to sleep knowing that even though a goal was extremely ambitious, it was still an order of magnitude away from the theoretical possibilities. So fast forward 2.5 years, and now I can clearly see the collaboration at work that is producing results. And just like we have predicted, we are inventing some new things like new protocol. And now we are about halfway through the 5-year journey, and I can actually see the light at the end of the tunnel. I can see how factor of 1,000 could be reached. We still got a long way to go. So I just want to say that they are, I think the will of a few individuals, which what I really mean by is the members, the 55 members of Green Touch, the injection of their will and standing by the commitment to collaborate and trying to break and do new things will produce unbelievable results. And I want to take this opportunity to thank all of you and congratulate all of you. I think it is a important milestone. I think, for those of us who been in the industry for a long time, when we talk about the improvement in orders of magnitude, that is a fundamental change. And I just cannot be more impressed than what I am today. So proud of all the members who participate in this, and looking forward to another 2.5 years later. That in fact, when we actually reach that goal, maybe even more. I go around the world talking to customers, and more the energy efficiency is in their mind. Not just the business leaders, but political leaders as well. So don't underestimate the impact this work, this Green Touch Consortium has on not only our industry, but society at large. And it is really important that we use this kind of opportunity, this kind of milestone, to give additional push, additional momentum to this consortium, because I still think we have quite a bit of work to do. But again, I want to take this moment to congratulate you and allowing me to sleep better.
Thank you very much, Jung, for that perspective, and thanks again. We have opened up the webcast for some questions. You can write them on the tab. We have Deb McGregor with us, who's been capturing questions along the way. Deb, I think you already have a few lined up. I know there a lot of questions are coming in. We will try to separate them and organize them in a way that is broad. Which one do you want to address first,
Well,
Deb?
here's one that I'm sure is on everyone's mind, and that is to what extent can this be shared with customers? I'm guessing the question more is, when is this going to hit the market?
So, as with all these things, there's a sequence of events. You standardize, you bring it into product, and you get to market. One of the things, and that has a certain time frame to it, and it will be the usual kind of time frame as we would expect of, maybe 5 years out or so. But the most important thing is, of course, as things are required in the marketplace, we can accelerate things. Certain things can be fast-tracked, certain things can be prioritized and whatnot. So as we roll this technology out, or wireless or other technologies, we really work with the market and the existing standard bodies to help prioritize and get them out relatively quickly.
Gee, I think that the key is to try to get it standardized as fast as you can. I think with this Green Touch membership that is so broad, I would imagine we can put an accelerator on the process, because once you become standardized, then I think it's up to each individual companies to actually implement this, and I don't see why we cannot implement it fairly quickly.
Exactly.
Another question is, how does this demo meet the Green Touch target of a factor of 1,000?
So this demonstration is one step along that path, and I think one of the backups to the slides or whatnot, we have a roadmap that shows the individual technology steps that we are making towards that goal. The factor of 1,000 is not across all technologies. Some have higher ones because they have a different starting point in terms of efficiency. And so this is part of the roadmap. This is our first step in the Wireline one. It's a big one, but you can expect many other big ones to come as well.
Gee, maybe you want to say in more layman's terms, the reason that not every equipment has the same factor of 1,000 improvement you need to do because it has a different starting point. Maybe you can say a little bit more why that is the case.
Sure. So when we achieve a factor of 1,000, the factor of 1,000 is at the network level. When you consider the entire network, you have wireless, wireline on the access side, you have core optical transmission on the core network side, and when you compare something like wireless with core optical transmission is already very, very efficient. It has a very high utilization. The energy is fairly well constrained within the fiber, and so we don't expect to see a factor of 1,000 in the core. But what we expect to do is leverage that efficiency more and more across the rest of the network, so that overall the network reaches its factor of 1,000.
Here's another question that has come in. How does the power savings scale when the load on the link increases?
Yeah, thank you for that question. This is Peter speaking. So, as you have seen in the explanation, the bits are spaced in time that matches the clock periodicity of the subscriber rate. So, in this way, when you are watching a video, you're watching a rate of 10 megabit per second, and then it's every 1 bit in 1,000 that is selected. If, however, you're doing a fast video download, you're downloading it at a speed of a gigabit per second. And then you're selecting 1 in 10 bits. And then the processing is accelerated, of course, at 1 gigahertz. So you have a power consumption that is proportional to the rate. So the principle of energy follows load.
We have another question. Will the average consumer notice improvements like cost savings and faster network?
Yeah, so indeed, on one hand, this new technology not only reduces the power consumption in the optical network unit, but also reduces the silicon size, the memory size, so it will also improve the cost of the electronics. And this especially becomes important when the rate increases. So we have now 2.5 gigabit per second deployed. We have a 10 gigabit standard. We have even 40 gigabit per second in the future. And as the rate increases, the energy consumption also multiplies. So as the rate increases, this will become also more important in terms of silicon size. So and next to that, there is also the backup power for batteries. With lower power consumption, you can support a lifeline service with a much smaller backup battery. And also, again, that will help in saving the cost.
Our Orange colleague, do you want to say a few words on perhaps from a customer and operator perspective?
Yes, so these solutions can be interesting in terms of reduced power consumption for the customer, because it's a way to reduce the overall consumption of the optical module that the customer will have in his flat, for example. So it's interesting in terms of consumptions. As Peter said, also in terms of cost, there may be a reduced cost of the overall module. And in terms of traffic, this solution is made for 10 gigabit per second. So this could be compared to the existing solutions that are deployed today. It's 10 times the line rate than the existing one today. So there is an increased traffic for the customer and a reduced power consumption.
Great, excellent, thank you.
Okay, looks like I have just one more question at this point, and that is, what is the next technology we can expect to see out of the consortium?
So as I said earlier, there's 25 research projects within the consortium today, and that number continues to grow. We continue to focus a lot of energy on the access technologies, whether it's wireless or wireline, because those are where we expect the largest gain. So we'll continue to see steps of progress in both of those technology areas. But I think the other large area that we're going to see some exciting results is in the switching and routing area. As we go from optical transport and have to then process the packets in electronics, that's where we also see a fairly large jump in energy. And so the next demo is likely to be either in the access side or in the switching and routing side.
Thanks, G. Actually, this is Dan Kilper, chair of the technical committee. So one of the exciting things coming up, of course, is we're planning our next demonstration event in the fall around a technology called optical orthogonal frequency division multiplexing. And so we have a number of members actively working on that. It's being led by Karlsruhe Institute of Technology.
Great, thank you very much.
What about the device, or at the semiconductor level? Is there any new breakthroughs in terms of energy reductions that you're expecting?
We see energy reductions in terms of the circuit design, adiabatic and things like that, but not at the transistor side at this point in time.
Another question. Could you give us some idea of what is the energy gain compared to existing technologies?
Yeah, so to clarify maybe a bit more what we have been announcing in the video, so the energy gain in the electronics is more than an order of magnitude. We have shown a factor of 30. There are, of course, in a home gateway, other functions that also need to be improved, and we have a combination of research projects that will get us there. One important one, for instance, is the virtual home gateway. The processor in the home gateway is also an important consumer, and it is very hard to turn it on and off on that short cyclic periodicity that I have shown earlier, tens of milliseconds per second. So another way of having a more efficient processing is doing it in the network in a time-sharing fashion by virtualizing the home gateway and sharing that server amongst 1,000 users. So you don't have the instantiation of, say, 1,000 operating systems and processors. And that will give us, yet to be measured, but approximately, again, a factor of 10. And actually, we have INRI online who is focusing on that research, and maybe, Laurent, you can say a few words to that.
Yes, exactly, Peter. This is what we are currently doing in INRIA on the virtualization of home gateway inside the Green Touch consortium. So the goal for us is to aggregate a lot of services which are currently distributed at home and to put them somewhere in the cloud, somewhere near the network operator and the service provider. And by doing that and by observing some aggregation effects, we plan to have a reduction by a factor of 10 in terms of energy consumption. This demonstration, combined with the Bit Interleaving PON, will be shown in June 2012 in Dallas.
Great. So I see that there's no more questions. As you can see, there's quite a bit of work going on and quite a lot of excitement around these particular technologies. I want to let you know that this webcast will be available for download on the Green Touch website. It's www.greentouch.org, and you can download it later on today. I also wanted to let you know that Green Touch will have a booth, and our meeting is co-located with TIA in Dallas, Texas, this June. June 5th through the 7th, and at our booth we are going to have the large-scale antenna system as well as the BiPON up and running in terms of demos there, and you can see and touch and feel the demos live at the TIA event. With all of that, I thank you all for your participation. I hope you found this exciting as we do, and we will talk to you again soon. Thank you very much.